Hey everybody. We do have a sub today, but thank you for watching. I'll make about 5 or so minute videos for this lesson. Um, Fourth period, you get the quiz on Monday. When I'm back, sixth period, you're going to take it with the like. Okay. First thing I want to remind you, we have 2 bits. We have 2 values for each bit, 0 or 1. So this 2 becomes very important since we only have 2 numbers we can use in binary. And when you only have 1 bit, you can only represent 2 things, or 2 to the power of 1. This formula is really cool for that. When you have 2 bits, you can put a little 2 in here. So I want you to fill out this chart again. As a reminder, when we have 1 bit, 2 to the 1 is 2. 2 bit, 2 to the 2 is 4. 3 bits, 2 to the 3 is 8. This would be 2 to the 4, or 16, 2 times 2 times 2 times 2, and so on. If you notice, they're going to double every time. Oops, that's good. This chart can help us answer a lot of questions that are going to be asked. They're generally going to ask it in kind of a weird way. In this one, it's pretty straightforward. How many values can 2 represent? So I go back, 2 bits, bam, 4. Add 1 more bit, and just go up. Oh, I have 3 bits now, 8. I can do 8. It doubles every time you add a bit. Okay, so that's one of the questions for the warm-up. The second one's a little tougher. This takes some multiple steps. So this is a chart where you have to figure out how many children there are, so you can figure out how many bits you need to represent each child. So you can look at the bar graph. So okay, I want to know how many like red. That's 8. Then I want to know how many children like blue. That's 7. So I'm adding those together, 15. Plus 5, 20. Plus 9, 29. Plus 6, 35. So the number 35 is the number, and then that is a certain number of bits. I'm going to look. Bam, bam. 5 is not enough. I need 6. Okay. This leads us to some rounding stuff and overflow. The other period would have taken the quiz, but fourth period, you guys are just going to continue on. So this is about change. And we have $90 worth of $10 bills, 9 worth of $1 bills. That makes 99, 99.90. So that's the largest. We could give somebody 99.90 worth of change. The smallest amount we could give is 1 dime, right? So 10 cents. If somebody needed 7 cents, that's where we run into an issue. We can't do that. We have to round up. Give them 10, or we'd have to do some crazy math and like ask them for pennies, right? And that's the issue. That's why rounding becomes an issue, because computers always don't have enough memory to store everything in binary. But rounding is a common thing that has led to some problems. So that is going to be this for that video, and then we'll start on the next activity.